Good morning. I want to talk to you about something that I see all the time on flat earth videos. It's very common. People introduce or develop an argument in their flat earth videos that goes something like, I don't understand. Look at this. I don't understand. Because I don't understand, that's proof that it can't work. And I wish that people would, instead of doing that, try to learn why it works or how it works, or at least, sorry about that, or at least show why it doesn't work. What they think should be happening instead of what's happening in the video or the photograph. Um, they just kind of get on there and bellow about, this doesn't make sense, it can't work, how could it be that way? And if instead they try to show us what they think should be happening instead, it'd be really helpful. So let me give you an example of that. Let's see, where we go. Here we are. This is this video from this guy, Mr. Thrive and Survive. He says, lunar eclipses destroy NASA hoax model, all capital letters down here. And at the beginning of the video, he's setting up the situation here. Let's take a listen.
We're going to look at the impossible eclipse of January 31st, 2018, which decimates NASA's theory. Now, we have the sun rising in the east. This is early morning hours now. The moon's been up all night, and then it comes into the shadow of the Earth, supposedly. And the moon is setting down here. Now, I need to point out something that's going to become relevant to those who want to think this through. The moon is actually advancing down faster than the sun is moving up. This is going to become important when somebody who has cognitive dissonance tries to explain this shadow anomaly. And just keep that in mind. The moon is racing faster down than the sun is rising by about 5 degrees an hour. Is that right?
Yeah.
5 degrees a night. I can't remember what it is, but it's definitely going faster than the from our vantage point.
Thank you for the correction.
So we have, this is my crew drawing, of course, of the Earth, the sun about to rise this way and going down. Now, do you think the shadow would be on the bottom? Do you really believe that? Does that make sense to you? Well, that's what NASA says. You know, I mean.
Oh, no, it doesn't. That is not what NASA says.
Is this logical or illogical?
Let's see.
What if I did this?
Let's jump.
How about that? Would that be logical?
Let's jump ahead. So here's where he shows. I'm going to skip ahead a little bit to where he shows the moon. Here we go. So he's unhappy that the shadow is on
definitely
the top.
Less than halfway. Correct?
It's showing the moon go right. The sun's coming up. The moon's going down. That makes sense, right? If you're having an eclipse, it means a full moon, so the sun and moon should be opposite.
Look at the sun breaking the sky up. Unreal. Now, people would tell you that if you're up in a tower, a really big tower on a high mountain, you're going to see the sunrise earlier because it's a ball, right? Well, how far out is the moon? It should be seeing the sunrise. How high up is that? Way higher than any mountain on Earth. And yet it's got this shadow supposedly from the Earth on the north side, on the top side, I should say. Incredible. The people would ever believe NASA after this.
All right. So I'm one of the people who still believes NASA after this, and I'll show you why. I made this, where'd it go? I put it away. Here it is. So I made this little video for folks to help you understand. Let's try it. Let's take a look.
Good morning. I was just getting back from Brugger's Bagels, getting myself a nice set of coffee and stuff because I got a big house project to work on. But so I was using these tools. I thought I would help answer Mr. Thrive and Survive's question. So I made a little sun. That's my sun, my Earth, and the moon. And the question is, how does a lunar eclipse that is appearing in the morning cause the shadow on the eclipse to appear on the top. One of the biggest problems with flat Earth proponents is that they have they tend to think in 2 dimensions rather than 3. So I'm going to try my best to help you see why the shadow's on the top in a 3-dimensional model. So what I've done here is I put a little screw in the side of this represents our observer. And so the video that he showed is that there was a full moon in the daytime, or right at sunrise. So from the point of view of the observer, being the screw, the Earth is rotating and coming around and just coming into view of the sun. So it has to be that the person is about there. Okay, it's right before sunrise when the eclipse is showing. So what's the moon doing? The moon is moving in its orbit in this direction, the same direction that the Earth rotates. And so if it's going into a lunar eclipse, it has to be moving into the path of the sun, in line with the Earth. So in this direction must be pretty close, right? It would be perfectly opposite, right? So it's moving into perfectly full as the right as the eclipse is beginning. So it's moving in right here, and as it moves this way, and the shadow of the Earth is coming out like this, as moving this way, it's moving into the shadow. So I set this little kind of indentation here, and maybe I'll need to put something across here to make it a little more easier to see, right? The shadow is starting to come across the come across the edge of the moon right here. But what you have to do to think about it from the point of view of the person is you wouldn't look at it this way, right? The person on the ground, my little screw here, wouldn't see it that way. They would see it this way, right? So they would be down on the ground looking out across the horizon, and the moon is moving into view this way. So from that person's point of view, the shadow is on the top. Hope that helps you understand. Simple explanation. You just need to think in 3 dimensions instead of 2 dimensions. Now I'm going to enjoy my coffee.
Okay, so the one thing I would want to add to that, if I could go back and reshoot the video, I'd rather not, is that the people who are experiencing sunset over on this side of the Earth, like if I had rotated around and showed what these people are seeing, if we had video from the opposite side of the Earth over here, then those people would look over and see the shadow on the bottom, like he predicted. So it's just because the eclipse began at around sunrise for the people taking the video that it appears to be on the top. Had they been on the other side of the world and people experiencing sunset, then the shadow would have appeared on the bottom. So you just have to try to think it through. Like sit down with some, I just took some simple tools. I don't have fancy AutoCAD and all those computer animation software. I just like to think in practical terms and simple tools that I can grab off a shelf or things that I have on hand to show physically what's going on. So just try to do that, please, before you run off and announce that you have proof that you can upend NASA and all of a couple thousand years worth of science with a single video. All right, hope this helps. Thanks, bye. How do I turn this thing off?